Alright, logic fans, it's Ash. Here we hit our final section on quantificational syntax, section 12, 6.12, and here we explore theorems of logic involving identity. So, the text has been divided up in such a way that you get theorems without relations, then you get theorems with relations, and now you have theorems with relations and identity all mixed together. So we're going to see some really interesting, nifty results. And in order to garner these results, we're going to have to call upon all of our tricks, CP, IP, reverse engineering, modus ponens, modus tollens, all of our problem-solving strategies. In addition to all of that, we're also going to require a brand new axiom, our only axiom of quantificational logic. Let's rock. Okay, so perhaps the easiest identity statement to consider is, one of the very simple form, A is identical with A, right? A is A. And this clearly is a true statement, and it's clearly something, therefore, that should be demonstrable as a means of unaided logic, right? And unfortunately, we do not yet have a means to go ahead and prove this as a theorem of logic. So, recall that, a proof is a syntactic deduction without premises, right? So it's what you can prove using only logical assumptions. So let's go ahead and see how we can't go ahead and prove something like this right now. And we do that by way of introducing a brand new axiom. And of course, the law of the excluded middle and the law of non-contradiction are available still, so you're perfectly welcome to do things like for all x, fx, or it's not the case that for all x, fx, and this of course is a use of the law of excluded middle. So those two axioms are still available, but this is our only new one that is articulated purely for the purposes of quantificational logic, and I call it the reflexivity of identity, okay? And it very simply states, let gamma be any individual variable from gamma, not from anything. Where gamma is any individual variable, you can just simply write down this. So gamma could be x, y, or z. So you could write for all x, x is identical with x, for all y, y is identical with y, for all z, z is identical to z, with or without subscripts. Any individual variable, you are allowed to write this down, and it doesn't have to come from anything. You can just invoke it the way we invoke LEM and LNC. It's just a freestanding, available sentence for you to call upon. So let's do a couple of quick exercises to make sure you understand the rule itself, this new axiom. Okay, so in each of these cases, allegedly, the reflexivity of identity, our new axiom, has been used, axiom 3. So, is this a legitimate use of the axiom? Is this a legitimate use of the axiom? Is this? Pause now, run through them, solve it for yourself, and then we'll come back and do it together. Alright, hopefully you've had a chance to run through it and do it, but the first one here, A, this is absolutely a legitimate use of the reflexivity of identity. You can just haul off and invoke this. Same thing with B, so it doesn't matter which individual variable you go to, you can go to it. That's the way the rule is articulated here. Now, this is an illegitimate use of the new rule, okay? Do not do this. This is not okay. You cannot just go to that. We will, you can prove that this is a theorem, but as a use of the reflexivity of identity, this is not allowed, okay? This is not allowed either. You cannot do this. This is strictly prohibited as a rule of as the reflexivity of identity, as a use of our axiom, okay? This is also prohibited. You cannot do it. All right, you have to go to the y here as well, and you certainly cannot do this either. This is absolutely wrong because gamma is not an individual variable. Our individual variables are x, y, and z with or without subscripts and nothing else, okay? So these two are legit, all the rest are illegitimate. Do not do it. Okay, so for our first actual problem, let's go ahead and prove that A is actually a theorem of logic, right? You can prove this, not just a syntactic deduction, but a proof that A is identical with A. Pause now. Okay, hopefully you were able to get it, but you invoke our new axiom, the reflexivity of identity, and you could have done it to x or to y or to z. It wouldn't matter in this particular case. and then you just go ahead and you universally instantiate that to A is identical with A. And notice you could go to B is identical with B, C is identical with C, U is identical with U, V is identical with V. All of those would be permissible, but since the theorem wants it in terms of A, you go to A. And this is a very common combination on the reflexivity of identity axiom. What you do is you just sort of go ahead and invoke that everything is identical with itself, right? And then after that, you go ahead and universally instantiate it to get something that you need that way. I should probably mention that the reflexivity of identity for all x is identical with x is a fundamental law of thought. As you know, a lot of philosophers just consider it sort of fundamental. Everything is what it is, right? Everything is identical with itself. Pick anything you want from Santa's bag, okay? Any x, pick anything you want out of there. That thing you picked out, it's guaranteed to satisfy the following description. It's identical with itself, right? And of course that's true, and so it's important that it be demonstrable as a theorem of logic. And you know, a lot of philosophers put it on a par with the law of non-contradiction as a fundamental law of thought. Okay, let's look at some more examples. All right, in this case, go ahead and prove it's a theorem of logic that nothing is not identical with itself. Nothing is numerically distinct from itself. Pause now. All right, hopefully you're able to get this one, but we go ahead and we invoke the reflexivity of identity, and since we want this in terms of x, we invoke it in terms of x, and then we double negate inside and take this negation, move it to the outside using Qn, and we're left with this final solution. So that's a really nice way of demonstrating that nothing is such that it's not identical with itself. All right. Although we're sort of practicing using the reflexivity of identity to prove theorems, purely logical features of identity classically understood, it's important to realize that the reflexivity of identity, our new axiom, can be invoked in the context of a deduction rather than a proof. So from this premise, now you have a premise, this is a deduction and not a proof. See if you can't syntactically deduce this conclusion from this premise. You may have to use our new axiom in order to complete this deduction. Pause now. Okay, this is a really interesting case, and it uses a common technique, so make sure that you're really understanding this. So the first thing we do is we universally instantiate the premise, and we do it in terms of A. That way we can have an A is identical with A, which we know we can get from our new axiom, and that allows us to set up a modus ponens, okay? So this is a really nice exercise to see, oh hey, if I invoke if I universally instantiate an x on an identity sign to get the same thing on both the left and right, I know I can get that same thing just by invoking my new axiom. And so that's a really nice problem-solving technique. And here again, I want to emphasize, you see that it's okay to use our new axiom in the context of deductions rather than proofs. That is just fine. But let's get back to looking at some of the proofs so we can explore more some of these really nifty features, purely logical features of identity. Okay, so for this next problem, I want to prove a really, fundamental and natural feature, purely logical feature of identity, which is that identity is symmetric for any x and for any y. If x is identical with y, then y is identical with x, right? If a is identical with b, then b is identical with a. And we're in a position now to actually demonstrate this as a theorem of unaided logic, which is cool. And the neat thing about this particular demonstration is that it requires us to use a sort of sophisticated maneuver on the reflexivity of identity, our new axiom. So by way of getting started, though, I want to start fairly simply. Start by reverse engineering this. So this is what we're trying to get to. So this is just some scratch work. This is not our official proof. Imagine what this thing looks like devoid of all quantifiers. Okay, that's what I want you to do. Pause now. Okay, so if you imagine in your mind's eye, all right, what this theorem that we're trying to get looks like without the quantifiers on it, you start with it, and then you universally instantiate you take off the x, then you universally instantiate again, taking off the y, and the x goes to u's and the y goes to, let's just say, u stars, just for the sake of illustration. And what you're left with is this sucker, and that is a conditional. So there's your hint for how to solve this particular one. So go ahead and start trying to write up your proof now and use this hint that it's supposed to be a conditional, and I'll give you a hint or two more along the way. Pause now. Okay, here's your hint. You're looking for the antecedent here, or sorry, you have the antecedent assumed here, and then you're looking for the consequent, right, this thing, and then you want to get, then you want to close out, so you get this arrow, this, and then you can stack the quantifiers back on to create the desired theorem. But how are you going to get from this thing to this thing? I'll give you a hint in a second. Pause now. Okay, here's your hint. Alright, so you go ahead now, and what you do is you invoke our new axiom, the reflexivity of identity, and then, you're trying to get some kind of combination from this and this thing to yield that thing. How might you do it? Pause now. Okay, hopefully you were able to get it, alright, but you just sort of have to pay really close attention to how we can use identity substitution. That's the key. So you go ahead and you universally instantiate this to U1 is identical with U1. How do I know to go to U1? Well, I'm looking at what I want, and I want the U1 in the left-hand position. So this gives me a U1 in the left-hand position, right? So I'm going to use this line to substitute into this one. So this should actually be 3, 1. That's not a big deal, but technically, if we're following our rules with absolute precision, right? So we're using this identity, and we're going to substitute into this one, and we're going to replace the U right here, and that's a legitimate use of identity substitution. And this is a very common procedure, so make sure you keep this in your back pocket as a trick, okay? And having obtained what we wanted here in line 4, we discharge our assumption, and we write down our assumption, arrow, the last thing we got, and now we have this thing that we had sort of reverse engineered, and it's just a matter of building back up to our desired theorem. So we're going to want the y first, then the x, so the y first, then the x, and the y's are going to replace the u1s, and the x's are going to replace the u's, and that's QED. And you, of course, already knew coming into the course that identity was a symmetric relation, but what's different here is your ability to prove that identity is a symmetric relation. You're also aware, of course, that identity is an equivalence relation from our work in Chapter 4, and so that means that identity is reflexive, which we have from our axiom, the reflexivity of identity. Now you know that identity is symmetric, so to complete the proof that identity is an equivalence relation, it remains to be shown that identity is a transitive relation, and that is a problem that is left for the exercises, so be sure to check that one out and see if you can get that. Okay, since we're running low on time, we're going to spill into the next video where you will see some of the most sort of advanced logical properties of identity that we prove in this course. So really make sure you take a look for the second video on 6.12, 6.12b, so you can really see some of the fundamental important philosophical results about identity demonstrated.